Hey guys, welcome to another A-Level Maths revision video. Today we're taking a look at some more applied material statistics year 1. So its representation of data is, I won't lie, it's really dull again. Try and stick with it again, like I said, it does get there, but this chapter isn't particularly fun. So in this chapter, taking a look at the idea of histograms, box plots, just all that kind of boring material basically. So this first question here is looking at the idea of working out means, standard deviations, and just considering why we have outliers, for example. So let's just take a look at this question here, exercise 3a, question 4. So we get the right colour pen. So question 4. So we've got the ages of 9 people at the children's birthday party recorded. So the sum of the ages at this birthday party are 92. So that's what sigma x represents, okay? And then we've got sigma x squared there, which we will use later on for the standard deviation. So to get the mean, remember the formula for the mean is hopefully rather straightforward. If you want to work out the mean from a set of data, remember you add up the total of the data and then you divide it by how many data points you've got. So because there's 9 people here, them are the data points, the 9 people. So what we do is we take the sum, sigma x, and we divide it by n. Okay, but sigma x in this case is 92, n is 9 people, so we do 92 divided by 9. Okay, and this will just give you 10.2, so that's hopefully nice and easy so far. Standard deviation a little bit more complicated, but shouldn't be too bad because you do have this formula given in the formula book. So the standard deviation, we write that as the square root of sigma x squared. So that's where we're going to need our sigma x squared from up here for. We divide that by n, and then we minus this mean squared. So you can write this in 2 ways. The formula book, they write that as x bar squared, like so, or you might also see the formula written sometimes like this. Okay, so it's the same at the front again, sigma x squared divided by n, and you might see this. These are exactly equivalent, but this is given in the formula book rather than this, but it's the exact same thing. Remember, just x bar means the mean of the sample. Okay, so all we've got to do is start plugging everything in. So if you work this out, this would be 1428 divided by n, which is 9, minus 10.2 squared. Okay, plug that into your calculator and you'll get 7.36. Okay, so that's our standard deviation there. If you wanted the variance, you just do everything underneath the square root, or you can square that value there. But that's only if you're working at the variance, obviously, because we want the standard deviation, we do take the square root. So part B, we're told one of the ages is recorded as 30, so state with a reason whether this is an outlier. So the important thing here is the information that we're given before that. So we're told an outlier is an observation which lies plus or minus 2 standard deviations from the mean. So what we're going to do is times our standard deviation by 2 and then consider it from our mean there, 10.2. So it might be a bit easier if we demonstrate this. So 2 times the standard deviation, that gives us 7.36 times 2. So what's that? Well, that's going to be 14.72. Okay, so if we consider our mean, so 10.2 minus 14.72, and then consider 10.2 plus 14.72, because remember it's 2 standard deviations from the mean. Like so. Okay, work each one of these out individually. So this one will give you minus 4.52, and then this one will give you 24.92. Now, we're told one of the ages is 30, so all we need to do is essentially consider 30 where it's greater than this value here. Okay, well clearly 30 is right, so as 30 is larger than 24.92, then we can say this is an outlier. This means 30 is an outlier. Okay, Part C, so if we just clear all this just so we've got a bit more room. Part C asks for a reason why this age could be a legitimate data value. So just because it's an outline doesn't mean that it isn't part of the data. So why might it be a legitimate data value? Well, if you've got a children's birthday party, for example, that age 30, that might just be one of the parents, we could say. So if we just say, basically, could be a parent, could be a parent at the party. Okay, we don't have to be too extensive with it, just knowing that point there. And then part D here, given that all 9 people were children, we need to clean this data and recalculate the mean and the standard deviation. So essentially, when it says clean the data, what that means is we just need to get rid of that value there. Okay, so the value that I'm talking about is the outlier, this 30. So if we want to clean this data, we need to eliminate the outlier, or need to omit it. So how do we omit the outlier? Well, for example, if I take sigma x and I subtract 30, then that's what the sum of the ages would be without that 30, which would be 92 minus 30, so that's 62. And if we do the same for sigma x squared, obviously we'd have to subtract 30 squared off here. Okay. So that's 1,428 minus 900 to give us 528 there. Okay, so now that we've got both of these, we can now just work out the new mean and the new standard deviation. The only thing you've got to be careful of is obviously don't forget now, because we've eliminated one of the values, we have now 8 ages rather than 9. Okay, so the new mean, how would we work that out? Well, that's just going to be sigma x, so our new sigma x 62, divided by n, where n is 8. Okay, put this on your calculator and you'll get 7.75 there. Okay, so that's our new mean. New standard deviation, again just using the formula from the part B of this question here, was it part A? Part A. So we're working at standard deviation, so it's going to be our new sigma x squared here. So 528 divided by 8 minus the new mean squared. Okay, so if I just double check on my calculator, I'm not sure if I've made a mistake. Let's just double check it. So 528 divided by 8, and then we minus 7.75 squared, and then we take the square root of this. So that gives us 2.444 there. So 2.44. Okay, so that's our standard deviation there. And again, if you like the variance, you'd square this, or just don't take the square root of the inside there. But that's the end of that question. So quite a long one, but hopefully that's helped. Next question here, dealing with histograms now. This is a very standard type of exam question, leading into some more kind of further histograms. So these questions they're a bit tedious, but let's just take it step by step. So the first part, so for question 6 here, we're asked to write down the class boundaries for the 13-14 class. Well, the key idea here is if we've got a histogram, we're dealing with continuous data. So histogram, continuous data. Okay. Well, if we've got continuous data, that means the class boundaries here, class boundaries, will simply be, so basically subtract a half off the lower limit and then add a half to the upper limit. So it's going to be 12.5 and then 14.5. Okay. Or obviously I could write that 12.5 dash 14.5. Okay, so that's part A there. Part B now. So it's split into two parts. I'm going to just do them together, because rather than working out the width individually and then working out the height, you can kind of just do them all as one. So I'll just call it part B here. So we're told the histogram's drawn, and the bar representing the 13-14 class has a width of 4 centimeters and a height of 6 centimeters. So all we've got to do then is basically find out the height and width of the 15-17 class. So how do we do this? Well, let's just consider this 12.5 to 14.5. Okay, what I'd do here is do two rectangles, because what we need to work out is the scale factor height and the scale factor width. And once we've got them, we need to just apply that to the 15-17 class, because then we can work out the new width and the new height essentially. So if we work it out with the width for 2 here, so 14.5 minus 12.5, we get width of 2. Okay, so the width for this, that's just 2, so 2 centimeters. How do we work out the height? Well, consider the frequency for this 13 to 14 boundary class here, or class boundary. So what would that be? Well, the height is just the frequency, so I'll call it H. So that's going to be the frequency, 24, divided by the width, which is 2. So doing that, that gives us 12. So the height is 12 centimeters. So if we consider the one that they've given us now, we're told the width is 4 centimeters and the height is 6 centimeters. Okay, so how do we go from 12 centimeters to 6? What have we got to times that by? And now what do we have to times 2 by to get to 4? Okay, well, clearly 2 times 2 will give me 4, so we times that by 2. And what do we times 12 by to get to 6? Well, we'd have to times that by a half. Okay, so that now what we've got there is the scale factors. So scale factor height so the scale factor height is timesing it by a half, and then scale factor width, so I'm just writing this down so we've got it, that's times by 2. So now that we've got this, all we need to do is the same with the 15-17 class. So what would be the width of that class? Well, that's going to be, so 15-17, so we'd write that as 14.5, 17.5. So if I've got enough room, do it up here. So for 15-17 class, the class boundaries will be 14.5 to 17.5. So in other words, we've got a width of 3 centimeters. So we've got a width of 3. The height, what would we get for the height? Well, remember, the height is just the frequency divided by the width. So the frequency is 18, like you can see from the table presented here. And then the width is 3. So 18 divided by 3 gives us 6 centimeters. So now all we've got to do is use our scale factors here. So what's our height going to be? Well, the height, remember, is just what we've got here, 6, times by the scale factor of 0.5. 6 times a half gives us 3, so that's 3 centimeters. And then the width, remember, it's just the width we've got here, which is 3, times by the scale factor of 2. So 3 times 2 gives us 6 centimeters for the width. And there we have it. So that's kind of how I do it all together. I wouldn't specifically work out the width individually for one part and then do the height again separately. I just do them all kind of together. So they're very methodical questions. Take it step by step. Take your time. It's very, very easy to make a mistake with these type of questions. But these are very standard. You'll find plenty more examples within the textbook to have a go and practice with. But if there's any issues with that, please just leave me a comment. I'll try and explain it a bit better. The next question here now is just a little short one from one of the old exam papers, just looking at a box plot. So the context really isn't that important for this question. Basically, you've just got a box plot. The first part just asks us to work out the range of the data. So remember, the range would be the largest data point minus the smallest. So we can simply just put largest minus smallest. If that makes it easier to remember. So largest minus smallest, but remember this shouldn't be anything too crazy. This is just kind of like your standard GCSE maths, finding the range here. So the largest, now be very, very careful here. Remember this cross, you can't see it because I've got a white pen on a white background, but this cross, that represents an outlier. Now just because it's an outlier, we still include that as the largest data point. So where is this cross on my axis here? So that's 40, so that, 1, 2, 3, so that's 45, 46, 47, 48. So my largest is 48, minus the smallest, so your smallest here is this last point, okay? So if that's 10, that's got to be 9. So 48 minus 9, working that out, we get the range being 39, okay? So that's not too bad there. The IQR for part B here, remember the interquartile range, the fact that we've got the word range again, just give you a bit of a clue. Remember, interquartile range is the upper quartile, so Q3, minus the lower quartile, Q1. Okay, so upper quartile minus lower quartile, which we can write that as Q3 minus Q1, which, if we work this out using the box plot sketch for us, so that would be 25 there. 25 for Q3. So then if you're unsure what it is on the box plot, we just do it in a different pen. So this, that's Q1. This one here, this is Q2, otherwise known as the medium. This is Q3. This would typically be your largest value, but because obviously we've got the outlier, then that's the largest. And this would be your minimum here. So that's the min. Typically your max without an outlier, but either way, both of them can be the outlier, can be the maximum. But obviously with the outlier being there, that would be the maximum in this case. So that's just how you kind of basically illustrate the box plot. So we just need Q1, which if we look where that is on the box plot, so that's got to be 11, that's got to be 12. So essentially 25 minus 12 to give us 13, yeah, 13 there for the IQR. So like you see, only a couple of marks for that, nothing, you know, too tricky, just again showing some of the basics for this topic. And then this very last question here is quite a long box plot question. Again, the main concepts here are looking at the idea of the quartiles, so Q1, Q2, Q3, being able to compare box plots, for example, and being able to sketch your own. So again, quite important skills, but if you've done GCSE maths, there shouldn't be anything that you've not really seen before. So let's take this one question part by part, because there's quite a few parts. So part A here. So write down the time by which 75% of the children in school A had completed the run. So remember, 75%, well, this would be called the 75th percentile. But remember, the 75th percentile is actually just Q3. It's the upper quartile. Okay, so this is Q3, the upper quartile. So all we need to do is look at our sketch of school A here for the box plot. So it's a little bit tricky to see. This would be easy if you look at your own textbook. So that's 30. So that would be 35, 36, 37 there. So that's 37 for Q3. So it's 37, and what's the kind of units for this? So to the nearest minute. So 37 minutes. Okay. So that's just your Q3 there, because that's when 75% of the children had finished the run. The second part is actually to state the name, which we've already kind of done. So this is Q3, but we wouldn't call it Q3. We'd call it the upper quartile, also known as upper quartile. Upper quartile, or you could call it the 75th percentile, like we did up here. Either was absolutely fine, did get you the mark either way. But that's all you'll be able to say for that part there. Part B, we have to explain what you understand by the two crosses on figure 1. So the two crosses, again, on our sketch of the box plot over here, what do those two crosses represent? Well, we've already seen a couple of examples with these. Remember, the crosses just represent outliers. So the crosses just represent outliers. Okay, so they represent outliers. So just give a brief definition of what an outlier is. So an outlier is essentially observations which are drastically different to the other values. Okay, don't have to be anything in quite long, just a brief description there gets us both marks. Part C here asks us to do it on graph paper, so I'm going to struggle doing it on graph paper because I don't have any on the screen. So all I'm going to do is I'm going to do a sketch. I would recommend actually getting yourself some graph paper. Make sure you can do these quite neat. Make sure you understand how to plot. But if I walk through how you'd sketch this, we're going to use the information they've given us to write down the important things. So what I'd do first, before you even try and draw anything, is write down everything we need. So we need the min, we need Q1, we need Q3, I don't know why I've missed Q2 as well, we need Q2, and we need the max. Okay. Now sometimes they might be a bit kind of like fiddly here. They might give you, for example, the max, and they might tell you the range, so then you'd have to work out the minimum yourself. For this one, they've been quite generous. They've just given us everything that we actually need. So the minimum, so the least time taken by any of the children was 25, so that's the minimum. The longest time was 55, so that's our maximum. What else have we got? And then we're told the three quartiles were 30, 37 and 50 respectively. So hopefully it makes sense. If the three quartiles are 30, 37 and 50 respectively, that means Q1 has to be 30, Q2 has to be the middle one, 37, and then Q3 has to be 50. Okay? And all you need to do now is just draw this. So if I just do a rough sketch, the minimum, so that'd be this little line here, so that's going to be 25. We'd then carry on up to where we get to Q1, which is 30. So we call that here. That's where the box starts. Okay, this carries on until it gets to the medium. If we say that's there. So that's 37, Q2. This will carry on now till it gets to Q3, the upper quartile. If we say that's there. Call that 50. And then this will just carry on until you get to the max, which is 55. So it might be somewhere like there. Okay, that's roughly what it's going to look like. Again, mine's just a sketch. Okay, so sketch. Make sure yours is much better. This is just a kind of a rough version, but it should look something like that, just to give you an idea there, using these values. And then finally for part D here, we want to compare and contrast these two box plots. So when you're comparing box plots, the main idea is to kind of compare the median, and then to look at the range of values or the range of the interquartile values. So if we look at the medians first, so the median for school B is the 37 that we've got, and then the median for school A is just 30. So what we're saying then is that the median time is lower for school A. In essence, at least 50% of the kids have finished before for school B, if that makes sense. So the median time, so on average, the kids at school A are a little bit quicker. The median time is lower at school A compared to school B. Okay. And then if we kind of look at the range in the interquartile range, well, if you work out the interquartile range for school 2, that's just going to be 50 minus 30, so that's going to be 20. If you do the same for school A, what you'll find is that the interquartile range is actually smaller for school A. So IQR is also smaller for school A. However, the overall range is larger for school A due to the outliers. So we'll also put that in. So, however, it has a larger range. Due to outliers. Okay, so I'm struggling to fit it all in. But there we go. Okay, so the idea here is when you're comparing, use the marks as a bit of a guide. 2 marked, we kind of want 2 points there. So that's my first point. That's just into my second. You could split this up into 2 points here, so you could have 3 in total. I'm just making sure I kind of exhaust all possible comments, really. But yeah, so that's kind of that question. Well, that is that question done. That brings us to the end of this video. So I hope it's helped. Not particularly the most challenging topic, but you know, a particularly dull one, so I can understand why maybe you don't want to revise it. But I hope it's helped. Any errors, please just let me know down below.